7.6. Solve systems of linear inequalities. So if you remember back when we were graphing inequalities, we were graphing one line, but now we're going to be graphing a system of them, which means multiple, at least two, up to maybe four.
On fire, bro. I did it.
Good work. All right. A system of inequalities consists of two or more linear inequalities in the same variables. That just means they both have to be like x and y or something like that. They can't be like x and y and u and v or something. What?
Wait, do we have a 7.7?
No.
Wait, so this is like it, and then we have a quiz.
Probably quiz Tuesday, test next Friday. But that'll be good though, because next week's a long weekend, so then you don't have anything over the weekend. It's President's Day weekend, so we're off on Monday. Not like 2 days from now, Monday, like next Monday.
I thought it was Martin Luther King Jr. Day.
Yeah, I mean,
That was January.
We didn't have two dreams. Only had one.
Only basically because you have snow.
Still banking on another snow day, guys. It's gonna stay as cold as it is. Might as well
Are
have
we
some snow.
serious right now? If it's gonna be cold, I want snow.
Amen.
Exactly. No point.
Alright.
All right. The solution to a system of linear inequalities is an ordered pair that is a solution
Stop.
Oh, I get this now.
of both systems.
I didn't see the
Now, there's going to be a lot of ordered pairs that would work, but if you remember when we graphed inequalities before and we were shading, I said take one point that's in the shaded area and check it in your inequality and see if it works. Well, the reason I said to get two different colors is because we're looking for the overlap, so that's why I said like red and blue. Where the purple section is, then that's going to be where your solution is, and any point in the purple area or whatever set of colors you choose to use is going to be the solution of both.
These are brown.
Yes.
So I missed out your question.
What does this make?
Blue and orange? I don't know. Probably make like a funky purple. I don't know. Or isn't orange like red and yellow?
Let's see.
I don't know.
I'm not in art class.
Wait, can I call Mr. Sturgeon?
No.
Please.
No. All right. Graphing a system of inequalities we're going to graph each inequality. I'm going to write this for Drew, like we did in 6.7.
6, 7.
Bro, lock in, bro.
That was just for Drew. I don't normally write that part. And then find the intersection.
No, it was not. Don't even. Well, it's not. It was easy for you because you have to study.
You don't study?
Well, I didn't know she was gonna change it up on us.
Miss Stacy has never done that.
She's not talking about me.
Talk about.
Yeah, do not talk about Miss Stacy like that.
Was it talking about?
Alright.
I was talking about Miss Hall.
don't have her, so I don't know what her deal is.
No, but she gave us a
She gives me attitude in study hall.
A bunch of kids cheated on vocab, so she made their quiz really hard.
I would never do that.
Yep.
All you do is go on Quizlet and it comes up.
That's cheating.
Everyone in the school does
I don't
it.
know. My hands just typed out the word.
Miss Patton makes you do vocab in class,
Yeah.
so you can't look it up. Hmm?
Rather than having it as homework.
No, we still have it as homework. We
You have part of it as
we
homework,
do,
but
like some of it in there.
because kids were cheating a couple years ago, and
Miss does what I was.
somebody ratted them out, and
Miss Stacy,
Trey.
is that you?
That's her.
Miss Stacy.
yeah, because they were doing it in front of me.
Who was?
They were literally looking at the answer, sitting in like right there where Sean's sitting in front of me,
Fucking.
and I was like, "Hey, you might want to change vocab," but she caught them anyways because they were using the wrong
I
word.
mean, it's pretty obvious when you're cheating because like you don't know anything on the quiz, but
Bro,
like,
not gonna lie, ChatGPT gives you all the wrong answers.
that's why you go.
Oh yeah, I gave a thing in geometry the other day, and if they had just Googled the answer, it gave them the wrong answer. It was great.
Wait, what do you mean?
It was like a worksheet, and if you put in the thing, like, it was like those punchline things, but it wasn't a punchline worksheet, but it was like that. And if you, like, typed in the thing and, like, the prompt and said, give me the answer to this, it gave you the wrong answer. It gave them the wrong shape. They had to, like, tell what polygon did it, and it said that it was a kite, and that was not the right answer. That was the least right answer.
So like everybody put it was a kite.
No, because I told them if I caught them cheating that they weren't going to like what happened, so.
What was gonna happen?
Wait, why did you tell them?
Hmm?
It was a kite. I told you them.
I didn't tell them.
Yeah, why did you? Wait,
I told them after they turned it in, and then they all freaked out. They were like,
Apparently, Google Classroom has an AI like checker.
yeah, it does.
You're serious.
Oh, yeah. When research papers and stuff get written, I go through and I check them for her,
For who?
for Miss Patton. I
Oh,
put
we
them
check it
through.
ourselves to make sure. Britta's was like 76% AI.
Yeah, I check them. It's really funny when I find somebody's entire paper.
I was just like thinking in my head. Imagine I used like ChatGPT on the essay he gave us for cheating. I don't want to know what kind of trouble I'd be in for that.
It would be interesting.
But if you get sentences, can't you just type it out once and make
You can't type them.
You have to write them.
Yeah. All right, so just as a refresher, if it is an or equal to, then you have a solid line. If it's just greater than or just less than, it's dotted. So that still applies when we do these as well. And then we're going to be shading in the correct direction. I think I'm going to count by twos on this one just because otherwise the graph's going to be really big. But are these going to be solid or dotted?
One is gonna be dotted.
Are you sure?
They're both going to be solid.
They're both going to be solid. Now, a lot of times I'll go ahead and use two colors as I'm actually graphing these. But if you want to just like use your pencil like normal and then just shade in the two different colors. And you can also just shade in a pencil, but I think that shading in the color is easier. So since this is the Y values, I'm not going to really put anything in the negative direction. I'm just going to do it like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My graph is big enough, so I'm just going to do it. All right, so Y is less than or equal to 10. So that means that I'm going to go up to 10 on the Y-axis. So that's up here. And I have a solid line going across. Now, where does this one get shaded? Below, because it's less than. So it's shaded down here.
Shade all of that, like just underneath it, or like.
Yep, the whole thing underneath of it. All right, then the other one, y is greater than or equal to 6. I'm going to go up to 6. And I'm going to draw a line across that way. And then does this one get shaded above or below? Above. Oh, I need the highlighter option, not that one. So notice it goes all the way above. My graph just kind of stops right above the previous thing, so I'm just going a little bit above it. But this whole region in here, where the colors are overlapping, is a solution. So what you need to do then is you need to draw an arrow to the area where the solution is, and you need to write solution. Okay, now it's this whole region in here. Obviously, you don't need to like do the whole thing, but just point to the overlapping area.
Like, point to the color?
Yeah, point to the overlap where the solution of the system is. Yep.
What is this, a solution?
Yeah.
Oh, yeah. Is it because they're like the same?
So if I picked the point, let's say 1, 7, and I plugged it in, well, obviously the 1 doesn't matter, but 7 is less than or equal to 10, and 7 is also greater than or equal to 6, so I can check it and make sure that it works. So I know I've shaded correctly.
Alright, so I kind of like forgot how to do this one on the lip.
Where'd 7 come from?
I just chose the 0.17 to check.
So wait, is it a solution because they're all like on
It's
the
a
same line?
No, it's a solution because the value in here, any number that I pick in here in this region will make both of these graphs or both of these equations true. So unlike the previous sections where we were finding one solution where our graphs intersected, or when we were using substitution or elimination to find where the intersection point, if you will, was, there's a whole set of points that works. But that doesn't mean that there's infinitely many, right? Like, it's not the same line, but my graph where the colors overlap is the solution. It'll probably make more sense when we're doing ones that aren't just like this.
Yeah, I'm kind of lost.
12. Y is less than negative 2x plus 3, and y is greater than or equal to 4. All right, so is this first one solid or dotted? Dotted, and what about the one below it?
Solid.
Yep. All right, on the first one, do I shade above or below? Below, and what about the bottom one? Above. So I like to go ahead and write all that out. Remember, too, if your equation isn't already in y equals mx plus b, you need to put it there first. But these ones are, so
Oh, crap.
I don't need to make that much.
Sorry.
All right, so my first line, I have a point at y equals 3. That's my intercept. I have a slope of negative 2. That's down 2, right 1, or up 2, back 1. It is dotted, so make sure that you pay attention to that. And again, same thing if you accidentally happen to do it solid, make a little note and put dotted. A couple people had to do that on the test if I remember correctly, and that was fine. All right, now we're below. We're where the y values are smaller. Well, my y values are smaller over here on this side. So it's going to be down in here. This one is getting shaded. Now my other one, y is greater than or equal to 4. So I'm going to go to 4. It's solid. So I'm going across through there. and I am shading above. So this area in here where the colors are overlapping is my solution. Now, obviously, I could have kept shading my blue up here if I wanted to, but we don't need to make our graph excessively large.
Does that look about right?
Yes.
I forgot. How do you know if you shaded it up?
It's based on, well, what makes it a true statement, but like the first one, y is less than all of this, that means where the y values are smaller. So the y is this axis here, so positive values are up here, negative values are down here. So that means smaller values are down here at the bottom, so I shade down here.
Do we have to draw the line with the color of like the shader?
No, you can do that in a pencil. I'm just doing it so that you can see where I'm doing everything, but no, you don't have to. Now, if I wanted to check a point for this one, I could maybe check the point -3, 5. So I plug that in. So I've got 5 is less than -2 times -3 plus 3. So 5 is less than -2 times -3 is +6 plus 3 is 9. Well, 5 is less than 9, so that works. And then using the same point in the other one, I only need the y value. 5 is greater than or equal to 4. Well, that's also true. So I know then that I've shaded in the correct spot.
I see.
Yes.
I'm confused.
About what?
Where do you get the point?
I picked a point that's up here in this area that's
You just
shaded.
picked a random one. Oh.
Yep, I could have chosen anything that's up there in that. I knew that a y value, anything above 4 would work, and then I just picked an x value that was over here in the negatives.
Wait, you started the solid line though?
What do you mean?
Like, for your point.
I just picked, the point that I picked is this one.
Oh.
It was in the both shaded areas. And the reason you check it in both is to make sure that it actually does work in both.
My bad.
14. Y is greater than or equal to 2x plus 1, or y is less than -x plus 4. All right, so my first one, is it going to be solid or dotted? Solid, and am I shading above or below? Above. And what about the bottom one? Is it solid or dotted? And above or below? Yep. Now, what you're going to notice is typically, if you're graphing two, in most cases, one's going to be above and one's going to be below. The exception to that might be if you have one with a positive slope and one with a negative slope. Obviously, this one we have one of each, but it could be the same, but more often than not, they're going to be opposite. One's going to be above and one's going to be below. All right, so set up the graph over here for it. So my first one, I've got 2x plus 1, so that means I have a point at 1. And then I have a slope of 2, so that's up to right 1 or down to back 1. That one is solid.
Wait, that's...
This is the top line. What is this one?
Oh. See, I knew I was the wrong one.
So then I shade above, so I'm looking for where my y value's bigger. Well, that's up here, because sometimes it's kind of hard to tell when the line is like almost up and down. So this one is shaded over here. Ooh, I like that color. So then I'm going to graph the other one. This one is dotted. I like to remind myself beforehand so I don't do the whole thing and then have to go back and fix it. So I have an intercept of 4 and a slope of -1, so it's down 1, right 1, or up 1, back 1. It's dotted. Now we shade below, so looking at that, I'm looking for where my y values are smaller. Well, that's occurring down here. So that means that I am shading all of this area down here below. Now again, notice I shaded the entire line. The solution is where they overlap, so where I have made dark purple. Okay, so on there, a lot of people like to only shade where they think the solution is, and they don't shade anything else. I will mark it wrong if you do not shade the entire graph. Okay?
You used to do that.
Hmm?
You do that.
Mark it wrong?
Yeah.
Yeah, I do.
Wait, not like shade wrong.
No. So this area in here where the colors overlap is the solution. So I could pick a point anywhere in here and I could check it. Okay, now since I'm using graph paper and I'm pretty confident, I could actually choose the point 0, 2 if I wanted to check that one. If you're not using graph paper, I would try to get something that's like more over here, probably just to make sure that you're, seeing it correctly, but you're going to know relatively quickly if you've shaded it correctly. So I'm going to plug that into the first equation. So 2 is greater than or equal to 2 times 0 plus 1. So that says that 2 is greater than or equal to 1. That's true. And the other one, 2 is less than -0 plus 4. Well, obviously that's gone. 2 is less than 4. That's true, so I know that I've shaded correctly. Are we tracking?
Yeah, I think it's pretty easy. Is this all we're doing?
Basically. 16, y is greater than or equal to -2, and then we have 2x plus 3y is greater than -6.
No, I hate this
What's wrong with this one?
one.
So, y is not by itself, so I've got to get it by itself. So, we're going to subtract 2x, so I have 3y is greater than -2x minus 6. Divide by 3, so y is greater than -2/3 x minus 2. Now, it doesn't apply on this one, but I'm going to remind you at this point that when you're doing inequalities and solving them, so getting y by itself, if at any point I multiply or divide by a negative number, what do I have to do? Yep, I have to flip the inequality. Now, I didn't have that situation here, but I'm just reminding you because I don't know if there's one that you might have that comes up like that.
Wait, what? Flip.
If you multiply or divide by a negative, you have to flip the inequality. All right, so on the top one, is this going to be solid or dotted?
Solid.
And do I shade above or below?
Above.
And then on the bottom one,
Dotted.
dotted and above. So notice this one, they are both above. I said normally they're opposite, but they can be the same. So, set up a graph.
Don't try that.
Huh? What'd you say?
Oh, nothing.
Did you say I'm not even going to try that candy cane?
No.
That's what I thought. That's what I heard.
No, I was gonna crack my back.
Oh.
I was like, I can't even do that. My shoulder hurts so bad.
I heard I'm not even going to try that candy cane. I was like, what? All right. Top graph. I have y is greater than or equal to -2. So that means I go to -2. And I put a solid line through -2.
Are you hungry?
Not really.
Because, I mean, you're just thinking about candy cane.
I ate lunch. All right, we shade above. That's all up in here. All right, on the other one, I have an intercept at -2. That happens to be at the same spot there. That would have been really nice if this was an equality. We'd already found the solution.
Inequality.
Huh?
It's an
An equality?
equality. Yeah.
It's okay. You're just living up to your hair color.
What?
I can say it because I am one.
Oh, one.
All right. So, slope is -2/3. That means I go down 2, right 3, or up 2, back 3. It is dotted. So make sure.
Wait, what? Thought we did a negative.
Now, this one's also shaded above, so that means it's shaded up here. So my solution is up here. So a nice easy point to check with this one would be what? 0, 0. I like those ones. They're nice and easy. 0 is greater than or equal to -2. Is that true?
Yes.
And then over here, if I plug in 0 for both things, 0 is greater than -6. Is that true? Beautiful.
So if we like get it really right and like we're like really smart that day, do you give us more work?
What?
Do you give us more work?
More work?
Yeah. If we like all get it like really good.
Like on homework?
Yeah.
Why would I give you more work if you know what you're doing? I don't work that way.
Oh well.
You can do 2, you can do 20. That's my opinion.
If I could do 2, I could do 20. Yeah, that ain't how it works.
Yes.
If you are capable of doing 2, like you know how
But
to
they,
do
like,
2, you should be
change.
able to do 20.
But they like change in the middle. Yeah,
Well,
you
I'm
go-
talking about of the exact same type of problem.
Alright.
All right, 20. X plus y is less than or equal to 10. X minus y is greater than or equal to 2. And y is greater than or equal to 2. What's different about this one?
There's 3.
There's 3.
What? So we need 3 colors now?
Or, just borrow from a friend beside you.
My friends don't got none. Where did you get that?
Just have 3.
Wait, no comment? Wait, did he say no or something? Yo.
Like, you can also, just have a friend that's sitting beside you that, used the color for the first one. You could use it for the second one.
Yeah, we were using the same color.
All right. So, I need to get y by itself in the top one. So, I subtract x. So, y is less than or equal to -x plus 10. You good over there? All right, that happened to me in geometry. Super awkward. Anyways, all right, the second one, I need to get y by itself, so I'm going to subtract x. So I have -y is greater than or equal to -x plus 2.
You said you're shut out on geometry.
Yeah. Then I've got to divide by the negative. So y is less than or equal to, I got to change the sign, x minus 2. And then obviously the bottom one is going to be what it's going to be. So on the top one, solid or dotted, and where is it shaded? Solid and below. Second one,
They're all solid.
solid, and where's this one shaded?
Below.
Below. Always use the manipulated one. And then the last one, solid, 8, and above. All right.
Wait.
1, 2, wait. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Close enough. All right, so first one, intercept at 10. Slope of -1, down 1, right 1. I'm not going up and back even though I can because I'm not making my graph any larger. It is solid. Now we shade below. So that means I'm down here.
Dude, I think I'm so good at this.
Cut your water.
All right, then the next one, we have an intercept of -2. Oh dear, I didn't go down far enough. Got an intercept of -2, so that's down here. I have a positive slope, up 1, right 1. I'm not gonna go down anymore.
Here's 2.
This one's also solid. This one is shaded, oh gosh, below. I'm gonna have to go down a little farther.
Yeah, your orange is dying. And it's not for me using it, I promise.
That's fine.
What would you do? Restart.
All right, and then the last one, y is greater than or equal to 2. So that means at 2, I have a solid line going across. It's shaded above. So the only place where they all intersect is right over here.
That little tiny corner.
This little tiny piece, because technically if I had made this line come down farther, ultimately it would be this little triangle over here.
I think I got it.
Don't die on us, Taylor.
Huh?
I said don't die on us over there.
Your dad got me sick on the bus.
Alright, any questions about this stuff? Alright, I'm only going to give you like 4 to do. But if you are struggling to understand or you need graphing practice, I would recommend you do more of them.
This many? 4?
Oh, Stacy, you need to give a lesson. Wait, what class is the 10th graders in?
Geometry.
Well, they're in 2 different classes.
Well,
Geometry.
whichever one Anthony's in.
Geometry.
Oh my gosh, his butt actually stinks. Like, I swear. I can't. It's
I
so
don't know how that's related to math.
No,